I suppose.
Okay, I've set it now.
Great. So, hi everyone. This is our Kids Research Seminar series, and today we have Manas Bhalla joining us today. And it's a great privilege to introduce Manas here, coming back to UCL because he was one of UCL's students and he was one of our excellent students who have graduated a few years ago. And he's now working as a software developer, software engineer at UBS. He's working at the evidence lab at UBS on various AI driven initiatives. I perhaps should let Manas introduce himself and talk about all the work that he's doing kind of at UBS himself. That would probably be better. So perhaps without further ado, I should pass the floor to Manas. Manas, thank you very much for coming to give us this talk.
Thank you, Karen. Thank you for the kind introduction. Hi, everyone. Thank you for being here today, and thank you to Karen and the entire Department of Information Studies for inviting me for the opportunity to speak. As Karen said, my name is ooh, the slide's not working. It is okay. My name is Manas, and I work as a software engineer in Evidence Lab at UBS. So Evidence Lab is an alternative data team, and it basically works in trying to provide alternative data insights for investment decisions. I work in the big data team within Evidence Lab, and I've been involved with generative AI in this team and a team prior to this for about 3 years now. My first generative AI project was in order to implement a generative AI Q&A feature that would replace, an extractive Q&A tool that was previously being used in one of our applications. It was one of the first generative AI projects at UBS, and I had the privilege of being one of the key generative AI engineers um, during that, actually. From that point forward, I was involved with a couple of different generative AI projects. Some were driven by business needs, some by different fellow engineers for technological needs, and some were personal pet projects of mine. Now, through a lot of these projects, some failures and some successes, I've gained some experience regarding what it means and what the reality of a generative AI implementation is within organizations. I've had some experience with the challenges it faces, but also the massive support it garners within organizations. Today, I'll be sharing some of my personal learnings and experiences, and I hope that that'll be useful for you, um, whether it's on your journey with software engineering, generative AI, or anything, to be very honest. So today we'll quickly review some key concepts surrounding generative AI. This is just to set the this is just to make sure that everyone has the same level of understanding of generative AI. We'll then go through the hype and reality of generative AI in general. We'll then explore the roadmap that these generative AI projects tend to take in organizations. And we'll use some sample use cases that have been inspired from my real world projects. I've simplified and exaggerated the use cases and findings in the use cases, so it's easier to see the key learnings and mistakes that I've made along the way. And I hope that these mistakes and learnings can help you on your journey as well. Now, so let's first look at the question. Let's first look at the question, what is generative AI? So let's quickly understand and review the key concepts of generative AI. Now, there are four key concepts here that often get used interchangeably and can lead to a fair bit of confusion. The first one is AI, or artificial intelligence. Artificial intelligence is the broadest concept here. It refers to machines or systems that are capable of performing tasks that normally require some level of human intelligence. Now, these tasks can range from reasoning, learning from experience, understanding language, and making simple decisions. For example, a simple rule-based system that flags fraudulent credit card transactions is actually a form of AI. It's not necessarily learning or evolving, it just follows human-defined logic. But it still qualifies as AI because it mimics quote-unquote intelligent behavior. The next one is machine learning, which is a subset of AI. It's where we move away from manually coding rules and instead feed data into algorithms that find patterns or make predictions. Essentially, it has the ability to learn from data. An example of this might be a bank might train a machine learning model on thousands of historical loan approvals in order to predict whether a new applicant is likely to default. The model over here will learn whether certain attributes lead to lower or higher risk. The key over here is that it discovers these relationships by itself. It's not explicitly told what the relationships might exactly look like. The next one is deep learning, and deep learning is a subset of machine learning itself. In deep learning, it uses neural networks. It's been loosely inspired by how the human brain works, and these networks have multiple different layers which allow them to capture very complex information. Now, deep learning powers things like face recognition, voice assistance, autonomous driving, but more simply, it's behind the technology that enables a system to identify the difference between two things. For example, a cat and a dog. The way a system can understand this is not because it has the ability to see whiskers, but because it's seen a million examples and has statistically learned what features might define a dog and what might define a cat. And the last one is generative AI, and that's going to be the main topic for today's discussion. So, generative AI is a type of deep learning. It doesn't just analyze data, but it has the ability to generate new content. For example, when you ask ChatGPT to write an email, it's actually using generative AI. It's using a generative AI model. These models, especially LLMs or large language models, have been trained on a vast data set of text, images, or audios, and have the ability to generate new output based on the prompt that was provided. Now, now that we've looked at some of the key concepts around this, let's actually look through how popular generative AI is. So, generative AI has become so popular that it's actually become integrated into our daily lives. A quick Google search now includes an AI overview. Several note taking apps, such as Notion, actually have AI assistants that have been embedded within the tool that allow it to be used very easily. Sorry about that. To allow it to be used very easily. Now, how popular generative AI is and how quickly it gained traction can actually be seen when we look at how quickly ChatGPT reached 100 million users. It took just 2 months for it to accomplish this feat. A report by Reuters mentioned that in the 20 years following the internet space, there might not have been a similar or faster ramp up in a consumer internet app. We can see that especially when we compare ChatGPT to TikTok, which took 9 months to gain the same amount of users, and Instagram, which took 2 years to gain 100 million users. Now, I believe that the extremely fast ramp up for ChatGPT was primarily due to two reasons. One of them, which was that generative AI was unlike anything we had seen before. It felt almost human-like. It felt like it had creative capabilities. Now, it didn't really have creative capabilities, but it felt like that for the ordinary user. Additionally, generative AI seemed like it had the potential to redefine the way we interacted with technology. And because of how easy and accessible it was for everyone wanted to get on the technology and use it as quickly as possible. Now, following the massive adoption by the general public, there was a massive surge in companies trying to develop AI-based solutions. In fact, a report by Crunchbase in 2024 found that VCs had invested over 100 billion in AI-related startups, and this was an 80% increase from 2023. This massive increase in AI funding was driven by the massive popularity in generative AI and the fact that companies were and still have been chasing to meet the required demand. Now, this wasn't limited to just AI-based startups. A report by McKinsey found that about 71% of organizations reported using generative AI in at least one business or technology workflow. It also reported that this was being used in a large variety of tasks, ranging from marketing all the way to engineering. Organizations reported on the rapid adoption and use of generative AI, claiming that it offers the ability to increase productivity and automate a certain amount of tasks. So we can clearly see that there's an extremely widespread adoption of generative AI, and it's at multiple different levels. But there's a bit more to the adoption of generative AI than just these overwhelming numbers might indicate. Now, the same report by McKinsey also found that 80% of their respondents reported that they weren't seeing the tangible impact of generative AI usage in their earnings before tax. Now, one of the reasons behind this might be that it's still very early days for generative AI, and we're also experimenting, trying to understand the technology, and we're trying to identify the best way that generative AI can really be used and implemented within organization. especially in a way that provides true value to one. Another report found that about 53% of employers were also struggling to find AI talent. Now, this was also preventing them from achieving the rapid growth of innovation that was required to extract true value from generative AI. Now, the problems that I've mentioned, the lack of AI projects not providing true value, and then also the lack of specific AI talent leads us to another concerning fact. And that was that a report by Gartner suggests that about 30% of generative AI projects are likely to get scrapped by the end of 2025. Now, as concerning as these numbers might be and what they might sound like, I believe that this is a natural part of new technologies. Sorry. As new technologies emerge, it takes some time for companies and engineers to begin implementing them in the right or ideal manner. I personally believe that generative AI is an extremely powerful tool. It's truly disruptive. We just need to be careful about using it and leveraging it correctly. Now, this also brings us to what a typical generative AI roadmap might look like in a typical organization. Now, over here, I think it's key to note that this particular roadmap might differ between organizations, but this is more or less the generic or has the key points and stages that are the most relevant when it comes to generative AI. Now, you might also feel that this is quite similar to a typical software engineering roadmap with just a couple of differences. So let's actually try to explore what each of these different stages in this roadmap are and why each of them are actually very important when it comes to creating a valuable and reliable product. So let's go through the first stage, and that's the ideation stage. This is the first stage, and during this, we're typically just trying to define what the problem statement is and trying to understand what the ideal solution would look like. During this stage, we attempt to understand what the real problem is. We ask an extremely important question over here. Is this even a generative AI problem? Now, this might seem like a very simple question, but in reality, it's a very important one. So, by asking this question, what we're trying to achieve is we're trying to make sure that this problem can, and more importantly, should be solved using generative AI. Because not every problem can and should be solved using generative AI. We're trying to ensure that we don't come across a scenario where generative AI is being forced as a solution, where some clever engineering or traditional machine learning model might be a better fit. This first step also helps us to avoid a rather costly endeavor. And oftentimes these type of endeavors where generative AI is a bad fit for a problem can also lead to a high amount of failure. Now, with this, I typically look at 4 questions. The first one is the output structured or semi-structured in nature? Now, the reason for this is because generative AI is extremely strong when it comes to using or creating unstructured outputs. Because if the output is a table, number, classification, or just a decision, a machine learning model might be a significantly better fit. The next one, does the problem require content generation, transformation, or interpretation? If the answer over here is no, it's not a really good fit for generative AI. And the reason for this is because whenever we're trying to interact with content, generative AI is a good fit for it. Whenever it's language oriented, generative AI is likely to be a good fit. Examples of this are like writing an email, translating, suggesting code, and so on and so forth. The next one is the output or input or output natural language. So the reason for this is that generative AI works best when it's trying to interpret or produce natural language. You can think of chatbots, report generation, doc summarization. All of those have the input or output at least as a natural language. And the last one, and personally, something that I think gets overlooked quite often is, does the task require a model or tool that is deterministic in nature? Now, deterministic over here means that if I were to put the same input with the same circumstances, I would get the same output every single time. Now, generative AI is not deterministic in nature, and that means every single time that you run the model, it will give you a slightly different response. And this is where it differs from some traditional machine learning models. So this brings us to our next stage, the POC stage. The POC stage is my personal favorite one. I spend a lot of my personal time creating these POCs, trying to validate ideas. It's also a great way to test new technologies at a very small scale. This stage is all about trying to validate that idea so we can achieve this solution, right? Now, a key point over here is that we're trying to replicate and design a problem at a smaller scale. So my personal way of doing this is that I'll try to identify a solution on a problem that is as close to the production environment as possible. And I ensure that I keep the scope as small as possible so I don't get overwhelmed with the amount of places that the solution needs to work with instantly. So an example for this is when I was trying to develop a multi-language support for a chatbot, to ensure that I kept the problem as close to production as possible while keeping the scope really small, what I did was I made sure that I only tested my chatbot with multi-language features on one document first. But I ensured that I used actual user questions and I made sure that I was able to switch between the languages relatively easily. By doing so, I was able to make sure that the scope for my chatbot was quite small, but the questions and the way that people would interact with it was extremely close to production. And this way I was able to validate my idea really quickly. Now, something I also think really helps with making sure POC is even more valuable is testing with negative cases as well. So I often find that by testing with negative cases, I'm able to identify the limits of my particular POC. So for example, if I wanted to make sure of what I did in this particular example was I actually put in different languages and languages that weren't supported to make sure that the model didn't hallucinate if an incorrect language was provided. Doing so helps to identify limits very quickly and also helps you to make sure that your solution is within scope. And whenever we go to business sponsors, you can provide them with this information from before. And this brings us to a third stage. Now, the third stage is something that's quite important, and I think especially very important for generative AI use cases, and that's the business sponsorship stage. Now, you might remember a stat from earlier where 80% of employers felt that there was no tangible impact of generative AI usage. This stage is to help prevent that from happening, or at least limit that as much as possible. This is because a business sponsor can help to translate the POC into a strategic initiative. They would help with the business and strategy alignment, and they would help to make sure that you can get your idea outside of the lab. This stage is also very crucial because it becomes an early indicator of how impactful an idea might really be and what impact it can make on the bottom line of the company. The business sponsor can often make impactful suggestions that can help guide your project or even improve your project at certain times. So this brings us to our next stage, and this is the development and integration stage. It's from this stage that we're actually starting to get our hands truly dirty. We now start making the idea and POC actually work in the real world. We're now faced with integrating the POC with actual infrastructure, front-end requirements, authentication, CI/CD, rate limits, API integrations. Um, we have different safety guardrails that must be put into place. And at this stage, we're not necessarily just experimenting, but we're more engineering a solution that is robust, compliant, and deployable. And that's the key for making sure that sorry, that's the key for making sure that our product is or our idea is successful in the long run. And this brings us to a next stage, the model review. The model review stage is quite common with generative AI use cases because this tends to be a stage where you're getting the model and use case both reviewed. You're getting the model and solution judged on the question against the question rather, is this safe, fair, and accurate? At this stage, a lot of the details are scrutinized. Details around accuracy, temperature, prompt, safety guardrails, and much more. At this stage, organizations tend to bring in experts from different areas, such as legal, compliance, security, maybe even an AI ethics panel, all to understand if the idea that you're putting forth is an idea that should go ahead. The next one is a pre-production or UAT stage. So this is after we get the green light from the model review committee. And it's the first time the use case will reach a controlled environment. At this particular point, there's very little human intervention, and the solution goes through stress testing along with its performance being measured against production or production like data and workloads. At this stage, were very closely examined against accuracy, latency, security, hallucinations, and any possible shortcomings. Well, at this particular point, we're trying to gain valuable feedback that can be used to fine-tune the solution. We're also trying to improve the prompts and add robust error handling in order to improve latency issues, in order to make sure that the solution is production ready. And this brings us to our last stage, production. So this is the day that's personally the scariest and most exciting. At this stage, you're trying to make sure that that whatever time you've spent developing doesn't break production and ensures that the use case is actually successful. Now, with generative AI in particular, production includes more than just deployment of the solution. It also means post-launch monitoring of the solution. Because over here, we need to monitor things as usage, accuracy, hallucination, and cost. Now, I hope that this roadmap and the stages have helped to shed some light on the journey of implementing generative AI and understanding that generative AI is not simply choosing a model or making an API call, but rather a multi-stage journey that requires a deep business and technological understanding, along with responsible AI practices. Now, let's go through three use cases to review the different stages and understand how an idea becomes a product on this roadmap. Now, these three use cases have been more or less inspired by actual real life use cases. I've simply simplified them and exaggerated the problems and learnings there, so it's easier for this presentation's purposes. Our first use case is leveraging generative AI to identify insights from a data set. Now, you might be thinking that this is an extremely generic objective, so let's try to streamline it a bit. Let's assume that all we're trying to do is we want to pass a compute usage log dataset through a generative AI model, and along with contextual information about the dataset, we want to then be able to ask the model for potential anomalies that might require investigation. So, since we're at the ideation stage, let's try to ask the 4 questions. The first one is the problem structured or is the output unstructured or semi-structured in nature? The answer for here is no. It's not. The output doesn't require to be unstructured or semi-structured, right? We would like the output to be as structured as possible because we would like to be able to pick up one single data point that requires investigation. The next one is, does the problem require content generation, transformation, or interpretation? The answer for here is also no. We don't require content generation, transformation, or interpretation. We will be providing a table. So that doesn't really fall in our realm of content or natural language content, at least. Additionally, what we would like to get picked up is a data point. As one specific row or one specific data point would be sufficient. So we don't need content generation over here. The next one is the input or output natural language. In this particular case, the input is not natural language. The output is also not natural language. So we can safely say that this is also no. The next one is, does the task require a model or tool that is deterministic in nature? Here, very simply, the answer is yes. We need a model that is deterministic because every single time that we were to run this model, we would need the same anomaly to be picked up given the same circumstance and same input. If the anomaly was only picked up 50% of the time, that's not useful the remaining 50% of the time. And we might end up missing certain points that require investigation. So out of the 4 points, we got a score of 0. So we know that this is not a good fit for generative AI. But let's actually still take this an example. Go ahead to the POC stage. So we can actually understand why these 4 questions in particular are actually so important. So let's look at this over here. Sorry. Let's look at this table over here. This table has just 4 columns: timestamp, service name, host ID, and compute usage. Now, let's assume that the question we're trying to ask over here is, using these compute logs, identify which components were behaving unusually, right? Now, for everyone who can see this table, I would like you to pay attention at these 3 points, the ones highlighted in red. As you can see, all of those 3 points have the first 2 points, right? On the 1st and 2nd of Jan, have a compute usage for the auth service well over 70%. However, on the 3rd of Jan, the compute usage, the CPU usage is just around 50%. And this indicates that something over here on the 3rd of Jan has gone wrong. Now, this is just a very small snippet of the actual data set. This is just so it's easier to read and I can get I can easily highlight the points that need attention. But when I was trying to run this through a generative AI model, these were some of the answers that I had gotten. The first one is that the auth service had an increase at 2 a.m. and requires investigation. Now, this is just quite incorrect. Now, the reason that this happened is because the generative AI model isn't actually able to look at the entire data set in one go. It's struggling to be able to pick up all the details from the data set. And as a result, this answer was quite useless. The next one, the auth service had an issue at 2 a.m. This also is not really useful because it doesn't tell us the date of it. Now, there were some responses where it included the date, but then it also missed which service it was in certain cases. So because of these type of answers also not very helpful. Now, the next one is no issues were found. Well, this is just quite frankly not useful at all because that's not the case. At the end of the day, there were certain problems that needed investigation at least. So we know that this particular model is a terrible fit, or this particular scope is a terrible fit for generative AI. Now, in this particular case, a traditional machine learning model would be significantly more appropriate. Now, in the real life use case, when we were discussing this, an idea very similar to this, that is actually what we ended up going with. We ended up going with the traditional machine learning model. The first reason for that was because traditional machine learning models are 100% deterministic. So they picked up the same anomaly every single time. The next one is traditional machine learning models are also significantly cheaper. They're also much faster to run, and they're very easy to fine tune and train. In this case, there are multiple ways that this can be solved. One way, especially if you don't have too much knowledge about machine learning models, a very simple way would be to leverage a time series model such as Profit to compare predicted versus actual in order to identify deviations between them. You could set a threshold of a point at which you believe that a deviation larger than this threshold should be highlighted, and you can then pick that deviation and that further. So with this use case, we unfortunately didn't make it past even our ideation stage. But adopting this roadmap approach and adopting those 4 questions helped to prevent us from going through the POC and a rather expensive and costly endeavor. Now, this brings us to the next point, and that is next use case, sorry, is using generative AI to convert natural language into SQL query. Now, this is quite a popular one, and it's been going around quite a bit. So let's try to understand how this might potentially work. So one of the ways that this can work is if we were to provide the schema and the sample data of any required table to the generative AI model, along with the question or any user question, the model in theory should be able to convert the question into an SQL query that could then be run against the mentioned table and return the desired result. Now, let's examine the questions to ensure that this should actually go past the ideation stage. So in this question, the first one, is the output unstructured or semi-structured in nature? In this particular case, the output is unstructured because it is an SQL query. So it's the next one is, does the problem require content generation, transformation, or interpretation? Yes, the problem does require content generation because we need the SQL query to be generated. It also requires content interpretation because we will be providing additional context and an input question and user questions that can change every single time to this particular model. The next one is the input or output natural language? The input is natural language, and the output can also be argued to be a form of natural language. But this is a maybe, but still, because the input is natural language, we will still go ahead with a yes for this. And the last one, does the task require a model or a tool that is deterministic in nature? In this particular case, the tool doesn't have to be 100% deterministic because there are multiple different ways that an SQL query can be written. Therefore, we can put this answer as no. And there are ways that we can lower or we can increase the deterministic capabilities of a generative AI model. We can keep the temperature and the creativity of the model as low as possible. So over here, it's a good sign we can go ahead with the POC stage. So let's look at what the POC would look like. Now, this is a very simplified model, simplified example over here. In this particular example, all I've taken is just one very simple table that denotes the schema and the schema over there. And I've asked it a very simple question. Show me savings accounts with a balance of over $10,000. You can see over here that it's able to generate an SQL query with a lot of ease. And that's because the scope for this is very small. The account is very easy to read. Now, in this particular case, once again, I'm only showing one table and one question. In reality, when I was working on a use case similar to this, I tested this for about 100 tables and I modeled them after some a particular framework in a particular data set that we had in production. I had also provided some sample data and additional context to each table that I was trying to have a SQL query for, but we can discuss that a bit later as well if you would like. Now, let's skip over the business sponsor stage for this presentation as well, because it would be quite easy to find a business sponsor for this, because it would massively help non-technical users query data quite easily, which is a massive pain point. Instead, let's actually look at what this would look like in development. Now, in development, we can see that the scope for this increases massively. All of a sudden, we're looking at a higher number of tables and columns. We're also once again now I've simplified the example over here, and I've highlighted and exaggerated the problems in each of these tables so it's easier to pick up on. Now, in this particular case, in the three tables that I've highlighted over here, you can see that there's not a single one simple column or naming convention for customer ID. And this is one big problem, especially if we were asking the question, find verified customers with more than 3 active checking accounts. We can see that there's no easy way for the model to actually join the tables that it requires. Additionally, because of the inconsistent naming convention, the SQL query that will be generated is likely to be incorrect. And there are some ways that we can resolve this. One way could be adding a loop and rerunning the model until a valid query is generated. You could also add a feedback loop that informs the model of the problem. But there's still a bigger issue over here, and that is with the quote unquote word active checking. Now, there's no single column that denotes active checking account. Instead, it needs to be inferred. The checking part of it will need to come from account type, or in this particular case, ACCT type CD, which has the abbreviated value of CHK, which in this case means checking. That's not really clear, is it? And because it's not clear for us as humans, it's definitely not going to be clear for a generative AI model. Sorry. And the next one is the word active. The word active will come from stat, which means status, and it has the abbreviated value of ACT, and that means active. Once again, it doesn't follow a semantic naming convention, and this is the big problem over here, that the data quality in production environments is not always of the highest standard, and also there can be a lack of semantic naming convention. Now, obviously, this is an extremely exaggerated example, but these are just some findings and some key problems that are very important and can hamper this product from becoming successful. But there is another problem, and personally, one that I think is much bigger. If you look at this example over here, I only have 2 tables here. And even if I were to fix all the naming convention problems and follow data quality and follow semantic naming conventions, here is a problem of ambiguous questions. Let's say I were to ask the question, list dormant accounts. Now, as you can see over here, there's no real naming convention problems. But because dormant account is a business term, every single company might define dormant accounts as different. Some might base it on if there's been no transactions in the last 12 months, 24 months, last 5 years. It could be based on the account status. It could be based on if the account has a zero balance. it might be a time logic where it says if the last transaction date happened at this point, or it could be anything. We don't really know. And because we as humans don't know, the model cannot know. And let me explain why this problem might actually be bigger than what it might just seem. The first problem here is that users, in order to use this tool, especially non-technical business users, would need to write very active and very specific queries. And because they might not know the exact columns, they might not be able to do so. And secondly, what happens if the model still attempts to generate an answer or generate a query and then run that query? In that particular case, it would be providing the user, the end user, with an incorrect answer. And that's a big problem over here. That's a big risk over here. And therefore, the user would then have to still rewrite and check the entire query. And at that point, it more or less defeats the purpose of this particular tool being just for non-technical users. So after trying to integrate this in development, we can see that small-scale implementation of an idea like this is quite easy. We have simple tables and semantic naming convention, but when it comes to development or enterprise interpretation, we notice that there are inconsistent naming conventions. There might be normalization issues, complex queries, unclear questions, different business definitions, and so on and so forth. So with all of these problems, it's clear that we would need to provide a lot more information than previously thought. And this would be a massive undertaking. Now, there are some ways that we can automate this and we can make this process slightly easier. We could automate the generation of table definitions. We could add business definitions. We could add clarifying question capabilities. We could offer suggestions that the model makes as the user types the question, and so on and so forth. And there are many ways that can be solved, but there is a risk of those unclear questions not being so easy to solve. So what we ended up doing was we ended up putting this idea on hold, especially because now there are actually a lot of data platforms that are already providing this feature. So with this feature, we've made it all the way till development and unfortunately stopped over there. So now let's quickly run over to our last use case, using generative AI for generating documentation. This would leverage generative AI models to generate .md files for existing scripts, and they would generate simplified and standardized documentation for them. Now, I'm not going to review the four same basic questions again, but rest assured, this is actually a very good fit for it because both the input and output would have to be natural language. This doesn't require the model to be deterministic and so on and so forth. So let's try to understand what this would look like and what a POC for this would look like. A POC for this would look like if you were to take a single script, a very simple script to start off with, run it through the prompt, run it through the model, and then get the generated documentation. Now, this seems very easy, and you would continuously do this and iteratively increase the complexity of the documentation until you were to reach a production level script. And doing so for one script is once again quite easy. So you would then need to understand and map out how one script is linked to the other, especially if it's a repository that is spread over. So you would do this and you would iteratively start doing this just to make sure that you are able to fine tune and improve the prompt as you go about it. And over here, the key effort over here would be with just the prompt during the POC stage. Now, in this particular case, let's take the example of this very simple script over here, rather a snippet of a very, very simple script, right? That snippet, we're passing through a prompt that we basically wanted to identify the functions mentioned, the packages used, and a quick guide on how to use this. And if you look at the actual documentation that's been generated, you can see that it actually does identify the package that's being used, which is Facebook Profit. It is able to identify how to use this, how it works, and so on and so forth. Once again, both of these are snippets, and both of these are extremely simplified examples of what this would actually look like in production. Now that we know that this model works and we know that it can actually work, let's try to move on to the development stage and how would this actually work, right? So in this particular case, there are many ways that we could integrate the solution. One of them would be with a DAG or data pipeline. So basically running a data pipeline through any orchestrator tool like Airflow or Databricks. And you could have that tool run this particular script every month, every day, every 2 days, every week, a year, so on and so forth, like however you would like. And this would then require zero human intervention. The other one is that you could integrate this within a GitLab or GitHub CI pipeline. So every time your packages are built, you could integrate this so it gets built without human intervention. The last one is you could include this as a build command in an IDE where users can run this when and how they would like. And they could then choose what documents they would like to be generated and which not. Now, each of these approaches has its fair share of pros and cons. I personally liked, and what we ended up picking up was the GitLab CI pipeline. This is because it's really good for picking up latest changes in a GitLab repository, generating documentation for it, adding it back to the repo, and absolutely does not bother um, developers one bit. It's a completely abstracted solution for them. And let's also understand why this actually would work so well. Now, the first reason this would actually work really well, or this actually did work really well in our case, was that there's very limited human involvement. Humans aren't expected to write good prompts, questions, or anything. All we really need is their code. And we expect their code to be of a certain standard anyways. Now, there's also very limited impact of this on production. Because this is creating documentation for it, even if this tool were to fail, it wouldn't break production, but at the same time would add a large amount of value for any of the developers that are actually working on these in this particular repo. This is also a very mundane task that all developers hate doing. I have not met developers who enjoy writing documentation, but every developer loves it when there's good documentation already written. Additionally, this is very truly a NLP and a text generation task. This means that it's actually perfectly suited for generative AI. And this is a great way, and this is a great place to understand that tasks that are generally meant for generative AI tend to perform a lot better in this case. As obvious as this statement might seem, it's a very important statement to understand.
Hi,
Now,
Mana. Just to draw your attention, we're coming up on 10:2, which is the so some people may need to leave at around about 10:2, but you may also want to have questions at the end, and so I just wanted to draw your attention to the time, because at the end of the hour, I think we are going to have to exit. So just to draw your attention to that. Sorry to interrupt. I know
no
you're
worries, no worries.
making good progress here, but just to draw your attention to that.
Sure, no worries. I think I'm on my last slide anyways. Yeah. So just a couple of key learnings over here, just to sum it up really quickly. So generative AI typically does require a deep level of understanding of business and technology knowledge. We realize this with the SQL query generator, where having that business context and technology knowledge would be essential if it were to be made a success. The next one is not all technologies, or not all AI problems are meant for generative AI. We notice this with the data insights tool. And the last one, there are many creative ways that we can actually use generative AI, and that's the real fun. We notice this with the document generator. So I hope this was useful for everyone. And if you have any questions about the technical implementation, feel free to reach out to me. Um, you can reach out after the presentation, or if you want, you can also reach out to me on LinkedIn if you have any questions as well. Thank you. I'm just going to stop the sharing over here.